Hi, in this video, I'll be taking you through how do you obtain the quadratic formula from the quadratic equation. So let's start over here. Let's say we have been given a quadratic equation of the form ax square plus bx plus c equals 0. So this is the standard form. So the quadratic formula for this is given by x equals minus b plus or minus square root of b square minus 4ac whole divided by 2a. As the highest degree of a quadratic is 2, you say there will be two solutions. One solution will be for the plus sign and the other solution will be for the minus sign. So we say these are the two roots. So we can write it as minus b plus square root of b square minus 4ac whole divided by 2a as one root, and the other root can be given as minus b minus square root of b square minus 4ac whole divided by 2a. So in this video I will be taking you through how do you obtain these two roots. So given this quadratic equation, we will use the method of completing the square form. So as we know from the previous video that in order to write a quadratic in the complete square form, the x square coefficient should be equal to 1. So in order to make the x square coefficient equal to 1, what we will do? So we will take a common from all the terms. So what you are left with? X square plus, as there is no a term in this, if we take a common, we have to divide a. So it becomes b over a times x plus c over a equals 0. Now, in the completing square form, we used to take the two terms containing x. And what will be the third term? What we want to do is we want to represent this in the form of x plus p whole square. And we know that the expansion of this is given by x square plus 2px plus p square. So you don't have this p square term in this expression. So what do? We consider the value of p as the coefficient of x divided by 2, or you multiply half to this coefficient and square it and add over here as well as subtract over here. So what we will do to this given equation, that is a times x square plus b over a times x, we are adding b over 2a whole square as well as we are subtracting b over 2a whole square plus c over a as it is. So all these terms are inside the brackets. Now if we simplify this, you can say if we take these three terms together, you can write this as x plus b over 2a whole square. How do you get this? You will say this value is your p, and if I multiply 2 to this and divide 2 to this, you will say b over 2a will be a p value of this. So we are mapping this three terms to the first three terms over here. So you get x square terms is x square term, the 2px, the value of p is b over 2a, and the value of p square will be b over 2a whole square. So we write it in this form, x plus b over 2a whole square. So there is an a multiplied outside to all the terms. So this can be completed as the second term that is subtracted remains as it is. We write it as b over 2a whole square plus c over a, and the bracket is closed, equals 0. Now if we multiply this a to all the three terms, we can reduce this to a times x plus b over 2a whole square minus a times b square over 4a square plus a times c over a. So we are multiplying this a terms to this term and this term. So this is equal to 0. So you don't need to put any brackets now. So you can give implies sign here as we are solving an equation. Now you can write this as a times x plus b over 2a whole square minus b square over 4a plus c equals 0. Now if we take these two terms to the other side, what do you obtain? You end up getting a times x plus b over 2a whole square equals b square over 4a minus c. Now let's write down here. You can solve this to a times x plus b over 2a whole square equals b square minus 4ac whole divided by 4a. So we are taking the LCM for these two terms. Now if I take this a to the other side, what do you obtain? You end up getting x plus b over 2a whole square equals b square minus 4ac whole divided by 4a square. Now if I take the square to the other side, you can write it as x plus b over 2a equals plus and minus square root of b square minus 4ac whole divided by 4a square. So the complete term is inside the square root. Now if you solve this, taking b over 2a to the other side, you can write x will be equal to minus b over 2a plus and minus square root of b square minus 4ac, and the square root of 4a square can be written as 2a. Alright, now if we take the LCM, it's 2a, we end up getting x equals minus b plus and minus square root of b square minus 4ac whole divided by 2a. So this is our quadratic formula. Alright, now we can obtain the nature of the roots out of this quadratic formula. So let's see how do you obtain the nature of the roots. So we will write nature of the roots. So the nature of the roots depends on the value that is inside the square root. So we will say this value inside the square root, that is b square minus 4ac, is known as discriminant, and it's denoted by letter D, or we can say delta. Now if this is greater than 0, so we will use the letter D. So if D is greater than 0, you say the roots are real and distinct. So you are telling the number inside the square root will be a positive number. So you can say square root of a positive number is a real number. So you are adding a real number to it and dividing it by a real number, because the definition of quadratic says if ax square plus bx plus c equals 0 is reduced in this form, we consider a, b, c to be real. As b and a are real and the square root of this number is real, you say the complete term will be real. Alright, now the second case, if you say the value of b is equal to 0, you say the roots are equal, because you will not add anything to this plus and minus. So the roots will be minus b over 2a. Now the third case comes, that is b is less than 0. You say roots will be imaginary or not real. So square root of a negative number is not considered to be real, so you say it's imaginary. So the significance of b square minus 4ac helps in finding the nature of the roots. So I hope you like this video, and please do subscribe to my channel if you have not done to stay updated with my upcoming videos. Thanks for joining.